Hey everyone, welcome to this 10x live stream. First I thought I'd say welcome to the people who have discovered 10x recently. I've had a few more backers, which is always great. Oh, that's nice. The shortcut shows me that. Okay, anyway. If you want to support, it's really appreciated and really does help me a lot. So thank you for those who have backed me recently, and welcome to 10x. So this is the third stream about memory, and hopefully the last. So I'm really excited to share with you what I've been doing this last month. I'm going to assume most of you have watched the previous stream, as a lot of this will make a bit more sense if you have. But as ever, feel free to ask me questions and I'll try and keep an eye on the chat. Ask questions as we go along. Hi. So, let's get right to it. So let's just check. Yeah, that's good. So it is now 3 gig. So it's gone from back in October, before I started the memory optimizations, it was 15 gig for my Unreal test project, which is a reasonably small Unreal project. And obviously 15 gig is a crazy amount. My target was 4 gig, and in the last stream last month, I got it down to about 4.5, 5 gig. Now I've got it down to 3, so I'm really pleased about that. The last unknown. When I started 10x, the main unknown was, could I write a C++ parser that was good enough to support editing and go to definition, find references, etc. That was the big unknown. But as developments continued, the next thing that came along was it was using an awful lot of memory, because I was keeping everything in memory, all the symbols, the data, everything, every single file in the entire project of tens of thousands of files, millions of lines of code. So once I'd got rid of the first unknown, which could I write a C++ parser, which I think now I've proved I have. It's still not perfect, but it just needs to be incrementally improved. I know it's going to work in practice. But the question was, could I get it down to a reasonable amount of memory? Because nobody's going to use an IDE that takes up 15 gig of memory. That's just crazy. So throughout the entire process of the years I've been writing 10x, I've always had it in the back of my mind, I'll just stream it in, or I'll just compress it or something. I've done a lot of memory work in my time, and I know there's always stuff you can do to get things to fit. But it's been a worry, could it be done? And I'm really pleased now that I'm convinced I have done it and it does work. And the other nice thing is there's no speed hit, which is good. And some things are even faster than they were before. So I'm really pleased with that. Compared to other IDEs, 3 gig is still quite big for a large project like Unreal. Other IDEs tend to take anywhere from 1.5 to 2 gig or something. The other thing you've got to remember is a lot of the IDEs use a separate process for the C++ parsing. So if you just look at the memory for the IDE, it might be like a gig, but then you might find another process somewhere of about 1.5 gig, which is storing all of the parser data. Whereas 10x at the moment keeps it all in one process, so it will look bigger. I might be splitting it off into a separate process at some point, because it'd be nice, just in case the parser crashes or something, it'd be nice not to take down the entire IDE. But for now, it's all in one process. But for me, if you're working on a big project with millions of lines of code, like Unreal, you're not going to be short of memory, typically. You're going to buy a system which has a lot of memory. And for me, I would prefer to use up slightly more memory, like 3 gig, but to have everything instant and immediate. Whereas other IDEs will do stuff on demand, so you open a file or go to definition, you have a progress bar, whatever. With 10x, it'll all be instant, and that is largely because I'm keeping everything in memory. Now, as I talked about in the last stream, I'm not actually streaming to disk to get this memory reduction. I'm actually compressing everything. So it's still all in memory, it just needs decompressing. So it decompresses on demand, which is typically very fast. Anyway, I covered that in the last stream. So this stream, I'm going to talk about what I've been doing since the last time I spoke to you, because when I spoke to you last, I thought I was almost done. I thought another few days, another week, and I'll be able to release it. And here we are another month on, and I think I've finished now, or at least I've done everything I want to do for now. But it took an awful lot longer than I thought. So I thought I'd fill you in on what I've been working on. Actually, before we do it, I'll just show you quickly the graphs, because I love graphs. So this is a graph I showed you last time. This is original before I started any memory optimization, and this is parsing the entire Unreal project, which takes a couple of minutes. So as you can see, it's getting up to around 15 gig at the time, just growing all the time. The blue line is what it was last month, so that was the first optimization I did, which is compressing a lot of the data. The purple line is how it is now, today. So I've done a lot more compression, and as you can see, it saved quite a bit of extra memory from last time. The green line is after it's finished parsing and then restarting, which gets rid of a lot of the memory fragmentation, etc., and allocator overhead. So the green line is what you'll typically see after you've done a full parse, which is now just over 3 gig. So as you can see, that's where we were, and that's where we are now. So quite a big difference. The other thing you'll notice is this purple line that we've got now is actually slightly faster than it was before. So this is where the parse finished here. And this is where it finishes now, so it's slightly faster. And the reason for that is because of mainly because of the allocators, which I'll come on to in a bit. So let's just look at the same thing in a bar chart. This total memory, that's what it used to be, that's what it was last month, that's what it is today, and that's what it is in the best case, where you've loaded up the cache, 3.2 gigs. So you can see quite a big difference, and that's 2 months' work, which is a lot longer than I thought it would be, but it's always the case. So what have I been doing? Yeah, compression. So as I said last time, I was using zlib just because it was easy. But a few people suggest I look at other compressions, so other compression libraries. So I looked at LZ4 and zstd. So zstd was good. It's the compression. This is the compression ratio. So all of the files compressed down to, with zlib, down to 12%, just over 12%. So that's already very good compression. So I wasn't really concerned about how well it was being compressed, because 12% is already pretty damn good. What I was concerned about is the time it spent compressing. So I'll just show you this graph again. The parse time in itself is actually about 50% what it used to be. So it should finish in half the time. And that's mainly because it's using less memory. But strangely enough, the time it takes to compress everything takes up the other half. So it's about what it was before, not a huge amount faster. So about half this time is compression. So I thought, okay, it's worth looking at another library, see if I can get it faster. So as you can see, zstd was good. It was 11% instead of 12.74%, so 14% smaller, but like I said, that doesn't really matter much in this case. It's only a few, like 100 meg or something, so it's not that big a deal out of 3 gig. But zstd was quite a bit faster, so 190,000 milliseconds versus 167. So that's a 12% speed up, which is good. I'll take that for no work. So I tried all the different settings and compression ratios and stuff like that, and I even tried training it. So that involves creating a dictionary from all the data that you know is going to get. It creates a dictionary of common words, and that in theory should increase compression speed and make it compress better. But unfortunately I didn't see any difference at all with that, so I don't know whether I'm just using it wrong, or there just isn't that much difference. But anyway, I tried that. In the end I went with the default settings, I think. I did try LZ4 as well, but as you can see that was for some reason really bad at compression. And I'm really not sure why, because I've used LZ4 in the past and it's been very good, much better than zlib. So I'm not quite sure why it was so bad. I tried it on the different settings, but it didn't seem to make any difference. And it was no faster than zstd anyway. So all I can think is it's something to do with LZ4 doesn't like lots of separate small compressed buffers, because I'm compressing each file individually so that I can decompress it on demand. And I think LZ4 just doesn't like that. It doesn't use the same kind of dictionary algorithm, I think, than zstd. So yeah, it didn't perform well at all. Anyway, it's worth a try. So yeah, I got a slight speed up in total parse time for that, which is nice. So compression of CP file def map. So as I mentioned before, I wasn't compressing everything that I could have been compressing. So for each file, it stores the text, obviously, of the source. It stores the token data for all that text, and it stores the defs, which are like symbols. So for each definition, I have a little struct which says what type it is and a bit of data about it. So I was compressing the first two, but I wasn't compressing the defs. So I added the defs in, and that got rid of about, I think it was about 600 meg. So that was nice. Okay, before we get onto that, I'll show you the Mempro. Let's load up Mempro Capture. So Mempro, for those of you who don't know, is my memory profiler, which you can find on my PureDev software site. And it literally just logs out all the allocations to a file and loads it up, and then gives you a breakdown by symbol, by call stack, which is very useful. So the nice thing about the Mempro Capture is it will capture all of the allocations. So I know I'm not missing anything at all. Just wait for it to take a snapshot. So as you can see, this big lump of memory is what it's taking up. Let's have a look at the call tree. So yes, hopefully you can see that. I can't zoom in, unfortunately, on this one. So what I've done, I think I explained this before, is I've broken down all of these call stacks using the wildcard filters. So basically all this says is that for any allocation call stack that contains CPP parse thread read cache, put it into this named group. So you can see, where's it gone? That one there. So it's useless. So the reason I did this is, well, one of the things I was finding is that some people who are using even bigger projects than mine were seeing a lot more memory than they should be seeing. So maybe they had twice the amount of files as I had in my test project, but their memory was more than twice as much. So what I needed to do was find a way of tracking what everybody was using in their memory easy. Now, I couldn't do this by using Mempro because it requires recompiling the source, and it's quite slow to capture this. So what I did was I added a new command, LogMemoryStats, which I'll show you in here. So if I do LogMemoryStats, can you see that? It's not great, is it? Actually, let's copy and paste it. Okay, so when you do LogMemoryStats, it just breaks down the entirety of memory into different categories and gives you totals for each subsection. Now, I've done this on a game engine and a game project, and it's absolutely vital to make sure you're tracking all of your memory and then break it down, by each category, each section of the engine, and make sure that you're A, tracking everything, B, you're not counting anything twice, which is a real problem. It can be a real problem that you realise, I've already counted that in a different way. So you've got to make sure you're tracking absolutely everything and give a high-level overview of where the memory is going. It's amazing how many engines don't have this. But until you've got a high-level view of how all of the memory breaks down, there's no way you can really decide what to focus in on. So I did this so that other people could send this to me of their projects, and I could see what was going on. But what I realised was it was missing a lot. So this is done by just every class has a get memory used function. It just returns how much memory it's using. It's not exact, but it counts the major stuff. But I realised there was about 30% of the memory that I was missing. So what I've got is in Mempro, I've got an exact. I'm tracking all of memory, and so all of these sections I can drill down into auto expand and find out exactly who's allocating the memory on each of these. So I know I'm tracking everything here. But here, I'm just doing it in code, and I'm not tracking absolutely everything, and I might not be tracking all the allocators. So the idea obviously is to get this to be tracking as much as possible. So I spent many days trying to cross-reference the Mempro with the LogMemoryStats and find out what I was missing in here. And obviously, it's not perfect breakdown just using a wildcard on a call stack. It gives you a kind of good idea, but there's not a direct one-to-one mapping between this and this. So I spent a long time searching through all these, making very detailed notes on what I'm tracking, how much it was taking, and then going back to the code and adding in extra tracking into the code. And so gradually, like I said, I was at about 70% coverage when I first started, and now I've reached 95% coverage. So I know I'm pretty much tracking everything now, which is really good. And a lot of where that was going was in allocators. So as I said before, a lot of the time I hadn't really cared about memory, so I've just been concentrating on speed of parsing. So I've been adding in allocators left, right and centre, not really caring what I'm doing, and just as long as it's fast, that's good. And a lot of the allocators were very wasteful. And I'll come on to that in a minute. And obviously there's also stuff that I was just missing, so I had to add in a whole load of stuff. So there's an awful lot of work in all of these stats. the nice thing is, like I said, now I can just tell anyone who's got high memory usage just to do this, run it on after they've parsed, run this and see where it's at. These numbers in brackets are counts. So, for example, the string table has 1.43 million strings in it, taking almost 300 meg. So, yeah, you might find it interesting to look at your project and see where the memory is being used. So in the parser, most of these things are just tables, hash maps, etc., various ways of indexing into the parser data. So, and that's why you get instant results when you, say, define references or replace symbol name or whatever. And that's what it's taking. So this CPP files section is what is being compressed now. So this section here, which is now taking 135 meg, that's what was taking like 10 gig before. And as you can see, compressed is now taking about 400 meg, which is really nice. So as you have more files open, this will increase slightly, but not a huge amount. You know, nobody's going to have hundreds of thousands of files open. So that's something you can keep an eye on. Right, what else was I going to say? So yeah, that's Mempro. So I think that's everything on there. So where's that? Yeah, 95% tracked. So that's really good. But that is probably what I spent most of the time on this last month doing, just searching for missing memory. So let's talk about that missing memory. And most of it, like I said, was allocators. So I had one allocator, which was the main allocator it uses when parsing, called the Parser Allocator. And because I'm using like all the cores on your machine, or most of them, as it's parsing, there's an awful lot of contention on the memory allocator. So I had to do something to stop all threads trying to allocate from the same allocator at the same time. So I created an allocator which just creates an allocator per thread. And that was great. It made it a lot faster. But what I noticed, there was a bug in, well, not so much a bug, but just something I hadn't thought about. The parser allocator uses what I call an incrementing block allocator. So it literally just allocates a block of, say, 4K, and then increases the index. So every time you allocate, it just adds onto the index. Because I don't really need to free at all. I'm just allocating, mainly when I'm parsing. I'm not actually freeing. So it can just be a straight incrementing index. And obviously that's really, really fast. And it worked well. But what I realized was that when I do a large allocation, it changes the size of the block it's allocating. So you say normally it allocates in 4K chunks, and that's fine when it's doing lots of small allocations. But then it comes to do a really large allocation, which it does occasionally in the parser, of like, say, I don't know, 4 meg or something, 4 meg allocation. It was changing the size of the block that it was allocating each time. So instead of allocating 4K blocks, after doing a 4 meg allocation, now it's allocating 4 meg blocks. And as I said, this is per thread. So each thread, so you've got 32 cores, you've got 32 of these allocators. If you just do one large allocation on each allocator, that's going to be incredibly wasteful. So that's just one example of some crazy thing I was doing in my allocators, which did not scale well at all. Anyway, that was an easy fix once I found it. The other thing I've done is I've changed a lot of the way it's doing the allocation, because it's now that I parse a file and then I compress it, and then when I need it again I decompress it. What I can actually do is just create an allocator, reserve a big chunk of memory for that file, use that, and then compress it, and then throw it away and start again. So the allocations patterns have now changed a lot since I'm now compressing everything. And the other thing is, when I decompress, I know exactly how big it's going to be because I can store that. So I can just allocate a chunk of memory exactly the size I need, and then it's got zero waste basically, which is really nice. The other thing I did, packed colors. Let's look at that. Let's have a quick look at packed colors. So basically the problem was, say when I do a workspace search, as you can see here, it's showing all of the results with syntax highlighting, which is great. But the problem is obviously that syntax highlighting needs the data from the parser, or the token data and all the text data, which is now compressed for all files. And you might do a search which shows, thousands of files and all the syntax highlighting. So obviously I didn't want to go and decompress half the entire project just every time you do a search. That would be really bad. So what I decided to do was, when I compress the file, I now store off just the color data for each line. So I'm not storing any token data or anything complex, just colors for each range. So for each, 1 second. So for each range, say like that, it's just literally an index length and a color, and another one for that, and another one for that. So each one is just storing a tiny amount of data, just a range and a color, and I can pack that in pretty well. And it turns out storing that for the entire code base is only, I forget what it is now. Where is it? Packed line colors. It's only 122 meg. So that's for the entire sort of 37,000 file project. So yeah, that's something I'm definitely willing to trade 122 meg, just so that find Workspace Search doesn't end up need to decompress anything. So as I said, it's just a very simple array of see, I haven't looked at this for a few weeks. So like I said, it doesn't even store the index, so I've just got a range which just has a length and a color. So for an entire line, I'm literally just storing no color for the first bit, and then green for that much, and then that much, that much. So you see what I mean? It's just a very, very simple structure, just stores all I need. And like I said, I only store that when it's compressed. When it's decompressed, I get the data from the tokens as I used to. So that worked really well, and that saved a lot of decompressing. So the other big thing I was doing is, over this month, is finding the various ways that stuff was being decompressed when I really didn't want it to be. Because like I said before, I haven't cared about memory, so I had all the files in memory, so I could just, if you wanted to find references, I could just search for every file and find all the references, and that was really quick because it was all in memory. But now it's all compressed. I obviously can't do that, so I had to change the way I do quite a few things. Search cache, talk about that in a minute. Oh no, let's talk about it now, as we're talking about Workspace Search. So the reason Workspace Search is so fast, you've got all these results, is obviously because it keeps it all in memory, but that's just the text data, so that's not too bad. I can live with that, and the text data for Workspace Search takes, where's it gone? Workspace Search, 380 meg to store all source files for a simple Unreal project. That's how much it takes. So I'm happy with that. That's fine. Well, actually, it's a lot better now because this was, say, about 600 meg before. And what I realized was I was storing everything in wide chars, so 2-byte chars. But most code, at least that I've come across, is just ASCII. So it can be stored in a single byte. Obviously, I still need to be able to support wide chars for other languages, but it's a fairly safe bet. I think that most code bases are single byte. So what I do is I just scan the file first before I cache it. So when I go through and cache all of these files in a project, I just scan the file first and check, is it ASCII? Yes, just store it in a single byte char. And obviously I needed to rewrite all the search stuff to cope with single byte char strings, which took a while. But it was a nice simple optimization. Like I said, it got it down from about 600 meg to 380 meg. So that was a nice little optimization. And also it will make it faster as well, because it's going through half the amount of memory now. So if the file isn't in ASCII, obviously it still stores it as a 2-byte char, and that should be fine. So yeah, hopefully for most people that would be quite a significant saving. Right, so that's Workspace Search. Yeah, finding references and finding symbols. So as I'm sure you know, the parser, you can do find symbol references. Actually, let's do it on a... So if you do find references on a symbol, it will show you everywhere that it's being used. And like I said, the way I was doing that was it just dividing it up over all cores and iterating through all files, all the parser and token data, looking for stuff, a bit like I do on Workspace Search. And that was pretty fast. But obviously I can't do that now that everything's compressed, so I had to totally rewrite that. Now I've got all the reference data already in the main parser database. So I've already got that information, I just needed to rewrite the way it looks for that data. So now it just goes through all those different maps I was talking about, like def cache, keywords by name, def node tree, def node hierarchy map. So these are all just storing the same data indexed in different ways. So for any symbol, I know exactly what files it's used in, so I can just decompress those files I need to, and not the whole project. So that was quite a big chunk of work, and it works very well. And I had to do the same thing for find symbols. So when you're doing find symbol, this was actually pretty slow on Unreal. I didn't realize, but it wasn't instant. And that's because it was searching through every file trying to find a symbol of that name. Whereas now I used the centralized parser database. So it's just iterating through one hashmap, for example, and I split that across the cores as well. So instead of iterating over hundreds of meg of different files, it's now iterating over one fairly large hashmap. But because it's doing it multi-threaded, it's almost instant. So that's one of the cases where things are a lot faster now than they used to be. So that's good. Question. Why have you decided to wchar versus UTF-8? Because UTF-8 is slow to manipulate in runtime. So most software that's dealing with strings, I would imagine, this is how I think about it, would deal with non-compressed strings. So I consider UTF-8 a form of compression. And, you know, for example, if you want to find out the length of a string with UTF-8, obviously you've got to do much more work than just count the chars. And my string classes don't support UTF-8 internally. Now, most editors, I think, would probably use 4-byte chars, because to get all possible chars, you really should store everything internally in memory in 4-byte chars. And I don't do that. I use 2 bytes because 2 bytes is almost always enough. You know, I don't know of any programmers who would need to use really wacky way out characters that wouldn't be supported by Unicode. But yeah, UTF-8, I'm sure some people are starting to use UTF-8 internally. And I'm sure there are some good string libraries out there, but I always prefer to write my own string class and string libraries. and it just makes everything a lot more complex. But yeah, maybe one day if someone writes a really good string library that isn't SDL or something that supports UTF-8, then it could be an option. But I don't really see that much benefit now. Anyway, hope that answers your question. So let's move on. So no emojis and strings. Yeah, I don't know. I guess emojis must use, I don't know if they use Unicode or not. But anyway, no, I don't support emojis because they're not supported by my font library. Sorry about that. So, compress, decompress, erasers. Oh god, yeah, this is the other thing. Big thing I've spent a lot of time doing is fixing all the bugs. Because, as you probably know, everything in 10x is threaded pretty much. Everything that can be threaded is threaded. And that creates a lot of complexity. It seemed like a very simple idea. Oh, I just compress stuff when it isn't being used and then decompress it when I need it. It's not quite as simple as that. When you've got multiple threads all wanting access at the same time, or you might be accessing it while it's being compressed, or one of the complex things was when you're editing code, it does a deferred decompress. So usually when it needs to decompress something, it just does it there and then because it's already on another thread, so that's fine. But when you're editing code, you don't want a stall of like 10 or 20 milliseconds just as it decompresses the file. So I put an async thing in there where it defers all updates to the file. So as you're editing a file, the parser needs to be constantly updating its text to match the text that you're updating. So I now defer those updates until it's finished decompressing, and then I reapply those updates after it's decompressed. So as you can see, it gets pretty complex. And there were all sorts of horrible races and things where stuff was compressing when it shouldn't be, and one thing didn't know another thing was compressing, and that was a complete nightmare, to be honest. And I've got a stress test, which I'm sure I've shown you before, where it just edits data as fast as it possibly can in as many files as it can. And it really is a stress test. I mean, it tests me as well, my stress. But it really just stressed the system, and that was throwing up an awful lot of race conditions and problems. But now the stress test runs for hours on end with no crashes, so fingers crossed. I hope that's fixed. Oh yeah, the other thing I did was, if the user is editing code, I mean, usually when it decompresses something like in a parser, it will, if it's not used for like 200 milliseconds or so, it'll compress it again. So if you just want to look something up in a file and then you're not interested in it, it'll decompress it, get the data, and then compress it again shortly later after. And that's what it does when it's doing the full parse, which is fine. That keeps the memory really low. But obviously, if you're editing code, you don't want it to keep compressing the file you're editing. Or if you say do go to definition, say I've got this file closed and I do go to definition on something, and then close the file, you don't want it to compress again. Because I'll probably want to do go to definition again, So anything that I've instigated manually, or I've done a find references or something. Well, actually, in find references case, you do want to keep it compressed. But if I do find symbol, for example, you don't want to keep compressing and recompressing stuff. So it sounds like a simple thing, but I did need to add. I've added, so for every function call into the parser, of which there are a lot, I've added a from the user flag to tell it whether that was instigated from the user or not. And if it is, then I'll set the compress delay to a day. So it'll only compress a file if you haven't touched it in a day. And that will apply to anything, like I said, go to definition on something. if you do go to definition, it will keep that file that you went to uncompressed for a day at least, and it'll only compress it if you haven't used it. So that should keep things really fast. So for most of us, we usually are just working in a subset of the solution. So even if it's a few hundred files, that should be fine to keep those few hundred files decompressed and never compress them until you move on to another area, and then gradually it'll start to compress them in the background. So again, like I said, that took a lot of time because I needed to add that flag to every single function pretty much in the parser. But that all works pretty nicely now. Switching configs. Yes, so as I've spoken about in previous streams, switching configs used to be very slow. It was fast to switch config, but then slow for the parser to catch up. And now it's using much less memory. I can keep the old config parser data in memory until the switch happens, and then I just switch to parser databases. And obviously, as it's using less memory now, reading in the database for the new config is very fast. You can do it in like 3 seconds in my Unreal test case. So switching is almost seamless now. When you switch from one config to another, you should see the defined out bits of code change almost within a few seconds. So that's pretty nice. Stopped preprocess storing indirect includes. Just looking at a comment. I see, yes, emojis are grapheme clusters. I haven't heard of that. But yeah, something different, obviously. So yes, 10x won't be supporting emojis, at least not in the near future. So yeah, preprocessor include files. Yeah, this is quite a big one actually. Something I hadn't really thought about. When I do the preprocessor and I'm scanning all the includes, what I was doing was storing a list of files that include this file. So for example, this header, all the files that include this backline cluster, for example, this file here would store a list of all these files that included it. And I was actually storing that as I was storing indirect includes as well. So for example, if I look at core.h, pretty much every single file in the entire solution will include core.h indirectly. So core.h would have a list of tens of thousands of files that included it. And the reason I need to store that list is because when I make a change, say to a define, so say I change configs and one of the platform defines changes, I need to update I need to pre-process all of the files that include this file. So that's why I needed that list. But obviously on a file like Unreal, on a project like any big codebase, to be honest, you often get into include hell, as I'm sure most of you have come across, where every file pretty much includes every other header file. And so on large projects, that list of includes per file was absolutely huge. Hundreds and hundreds of megabytes. I can't remember exactly how much now. I think it was something like 800 or 900 meg. It was absolutely crazy. And when I realized what was happening, the solution was obvious. I just need to store direct includes. So I only store the files that directly include core.h. And then when I change core.h, I can just find all the files that directly include it. For example, other header files, say array.h, will include core.h somewhere in one of these includes, and then update that file, and then recursively update all the files that include array.h, for example. So I'm basically walking the tree or the graph of includes rather than storing the indirect list for everything. And that took it down from, like I said, hundreds and hundreds of megs down to 2.5 meg. So that was a really nice include, really nice optimization. So as you can see, lots and lots of little things like this, which you don't kind of think about until you would work on a really large project and it just throws up all of these things. Right, what next? What are we doing for time? 50 minutes. That's pretty good. So miscellaneous stuff. Yeah, I just went and rewrote all of my container classes, or at least reworked them. Objarray is my array class. Mostly for arrays, I just use a pod array. But for complex classes, I use Objarray, which does all the proper constructor and copy operators and stuff like that, rather than just using memcopy when it resizes, things like that. And I wasn't happy with the way I'd done it. It was an experiment I did quite a few years ago, where I store a list of pointers into an allocator. So rather than storing the objects actually consecutively in memory, I store the array is actually an array of pointers. So in turn, the object array was an array of pointers, which made inserting and removing and resizing very fast. And it was good, but I realized that I had lots and lots of very small object array classes, and the overhead of having an allocator for every array and two separate chunks of memory, one the pointer array and two the allocator. Because I had so many small object arrays, it was taking up about twice the amount of memory for a lot of things. So in the end, I just went and changed it to a normal, as you'd imagine, array class, which stores it consecutively in memory. So that helped a lot. And I don't usually abuse my array classes and insert and remove and stuff. So there wasn't actually any speed benefit from doing it the original way. Hashmap P2, can't remember what I did with that. I think I just standardized all because I've got 3 or 4 different hashmap classes, and this is the one I use mostly. P2 just means power of 2, so I think I've talked about hashmap in one of my other streams, so I won't go into detail on that, but I have a load of hashmap classes, and they were all slightly using different allocation strategies and slightly different algorithms, so I just standardized all of them. W-string hash is another, so it's a hash table specialized for storing having keys as strings, and again it's very similar to hashmap P2. So I just took all of my hash maps, standardized all of them, and some of them I haven't touched for like 10 years or more. So that was a pretty big change, and again it just got rid of a lot of allocator overhead, unnecessary overhead, and I also did quite a bit of work on the hashing again, to try and improve my hashing of IDs. And I tweaked my container growth rates. I found some of them were just growing at 50%, and now they all grow at times 2. Text file not actually being closed and files closed. Yeah, I realised that internally for every file you open, I store the text, and say, for example, if you duplicate a panel, so for example, if I say duplicate right here, these are now both pointing at the same internal 10x test file class, and I realised that when closing a file, it wasn't actually closing or destroying that, it was just hanging around. So any file you ever opened, it was just hanging around, which is not too bad in terms of memory, but I realized it was causing files not to get compressed, because the parser needs to know when that file is closed before it can compress the data. So that was just a silly little bug. Another silly little bug I found was a lot of my allocators, when I do reserve 0, it was actually allocating a chunk of memory. So say, like I said, I had one of those incrementing block allocators that increments in 4K chunks. Doing reserve 0, which you'd expect to do nothing, was allocating a 4K chunk. And now that I'm compressing everything, when I read the cache in, the lines are 0. It doesn't have any lines. And so the code I had in there originally that was reserving all my allocators ready to load that huge amount of data in was now reserving 0, which is fine, but I realized that reserving 0 is actually allocating a chunk of memory just for no good reason at all. So that's gone now. Oh yeah, I talked about Knuth hashing and hashmap. I talked about that a bit on Twitter. So I won't go into that again. In my red-black tree for my map class, I packed the red flag into the parent pointer, which saved a little bit of memory. So these are just examples of some of the optimizations I was doing. None of them on their own were that much, but it does all add up. Stop database get function searching through and decompressing all CP files. Yeah, I can't remember exactly what get functions is used for, but it's just another case of stuff in a parser decompressing a whole load of stuff that it really doesn't need to. Oh yeah, the best one with find references was the syntax. When you click on a symbol, for example, it's highlighting all occurrences of that. That's actually using find references, the same thing as when you do find references on it here. And this is finding references in all files. And it does this just because I was being lazy at the time. When I did this symbol highlighter, I was just using the same thing. And what I realized was that when you clicked on a symbol, it would decompress all files that contain that symbol. So for example, if you clicked on array, it would, why is that not working? Strange. Oh, I think it doesn't work on arguments for some reason. That's weird. So, that's interesting. Still not working. Maybe it's just there's something still wrong there. It's being too slow. So it should be highlighting. If you click on it, it should be highlighting all occurrences of that. But anyway, I'll look at that later. But what was happening was, as I said, it was going through every single file and decompressing everything. Whereas all I'm doing is highlighting instances in this file. I don't care about all files. So I just had to rework that and write a special find references for just finding references in the file you're currently in. So all fairly obvious stuff once you see it, but there's just so many things that I just didn't think about until it came to it. Initialize all fonts. White space is true special. Oh yeah, when it comes across a non-ASCII char that isn't in the font you're currently using, so for example a Japanese character, what it does is it scans through all fonts on your system and tries to find the best font it can that contains that glyph that you want to display. And when it does that, it was caching. It was loading up all fonts on your system and caching them in buffers, and that was taking I think it was 150 meg or something, which is quite a lot. And it really doesn't need to do that because it's not that often that it needs to look up special characters. So I just removed that code. So now every time it just scans through the fonts on your system and gets it. So you might see an odd glitch occasionally if the first time you're loading up a file with a different character in it. And I realized that white space was being treated as a special char. I think it was just the new line or a tab or something crazy. So when it found that, it was thinking, oh, I've got to go and search for that glyph in all the fonts, which again, it didn't need to do. So that was that. Right, I'm almost exactly on an hour. So yeah, if anyone has any questions, now would be a good time to ask them. So this build, the memory savings isn't live yet, simply because I'm just going to be taking a few days off in a few days' time, and I didn't want to release a build to the world that was hadn't been tested as much as it could have been, or just in case there are any problems and I wasn't here to deal with them. So I've just sent out a link to people who are on my subscribers Discord channel. And if anyone wants to try it, just DM me and I'll send you a link. But I'm not going to release it just yet. So it'll probably be on Monday or Tuesday next week that I'll release it, assuming nobody has any problems with it. But yeah, I'm really looking forward to everyone seeing this build, and I think it will really improve a lot of things in 10x. So some feedback. I'd be interested in a stream on how you render the text views. Yeah, sure. I'm happy to do that. Yeah, I don't know what next stream's going to be on, so could well do that. I'm trying to think if I'd covered that in one of my earlier streams last year. Yeah, I don't think I have actually. Yeah, I'll have a think about that. So what am I doing next? There's still a few things that are outstanding that I just really need to fix before I can consider 10x feature complete. One is the find and replace in files. I still haven't got a find and replace, which is a bit embarrassing for an IDE. I mean, most of the time you can just use the Workspace Search and it's fine, but sometimes you do need to get a list of things and do replace as well. The docking, as I think I said before, needs a bit of attention, needs a bit of a rework. And then it's just issues really. I mean, I'm at the place now where I think I'm really excited about this build because, like I said in the beginning, the memory was the last unknown. I proved that I can do C++ parser. I proved that I can now fit it into a reasonable amount of memory. And yeah, it's all go now. Like I said, just a few smaller things to do before I can probably call it feature complete. And then maybe even move out of beta, I'll see. I mean, the GitHub issues, I've still got a lot of issues. $441, and a lot of these are features as well, which I know people want. So I need to go through and triage this again and see exactly what I need to come out of beta. I have started. See, I had some labels here. I have started labeling things for beta. That means blue means to come out of beta, to be basically feature complete. But I haven't updated that for a while. So I'm probably going to go through again and just see exactly what I need to do and then start prioritizing. But there are no major big features that will take, weeks or months to do anymore. Now it's just the long slog of, finishing this marathon before I can release 10x to the world. And it's going to be really helpful if I can have feedback from everyone on what things are the most important. So now my mindset is, what are the things that I could not release 10x without? If there's something that just has to be done, what do I need to get to feature complete? So I'm going to be very careful about adding new features now. I know there are still lots of features people want, but unless it's something that the vast majority of people will want, I'll have to just keep it on the backlog for now. But like I said, I do want feedback, and if everyone says to me, we need code folding, for example, then I want to know that, and I can still prioritize things. But now, like I said, the push is to get to feature complete. Okay, another question. Does the editor support multiple cursors like Sublime text? If so, a stream on how that works would be interesting too. Yes, it does. I can definitely do a stream on that. But guys, I don't often use multiple cursors myself, so I kind of forget all the shortcuts. But the one I do like is Control D. I find that very useful. So you can select, put a new cursor on every occurrence of the word, and then edit them in unison. And obviously it also has the block select, and that's creating a cursor for each line. I think it's Shift, no, Control. Yeah, or Control adds a new cursor to each line. Anyway, I can go through that in more detail at some point. But it should be fairly similar to lots of other editors. If you're ever wondering, does 10x have a certain feature, the best way is to look in the menus, because you'll see all the features with all the shortcuts as well. So, for example, multi-cursor has its own section there, and you can see most of the stuff with its shortcuts there. The other thing to keep in mind is right-clicking on a tab. You get all these. Someone didn't realise that I had Perforce integration. Right-clicking on the tab gives you all that, all the Perforce commands as well. And then obviously right-clicking on here to give settings for the project and things like that. Anyway, I do want to do some more streams on, say, for example, setting up 10x workspaces and things like that, which aren't immediately obvious. Just so that to give you a better idea of how to get the most out of 10x. So yeah, any other suggestions are more than welcome for that. Because once I've finished the main features like this, I want to carry on doing these streams, and it'll be more about how to use 10x rather than how 10x works internally. But as ever, I'm open to suggestions of whatever you want me to talk about. C# parser when I'm gonna have to focus on C++ first. So I need to get 10x out as a shipping product soon, because I haven't got an infinite amount of resources or money. So to do that, I'm going to have to focus, unfortunately, just on C++ at the moment. But once I've released 10x and come out of beta, got feature complete, and got rid of a lot of the issues and bugs, then definitely I'll be moving on to C# and other languages. And obviously Python support I need as well. So yes, it's definitely on the cards, but I can't say when yet, unfortunately. Does it support C99, C11? I'm mostly interested in designated initializers. Yeah, I don't have designated designated initializers yet, but I don't think it'd be too much to support. So yes, there's still some work I need to do on the parser to support various bits and pieces. And like I said, the more people that ask me for a certain thing, the more likely it is I'll prioritize it. So yeah, do let me know the things that you really kind of need day to day that you're finding are missing. But hopefully a lot of these things shouldn't be too much work now. I just need to know about it, because obviously I can't just look through the C++ specification. That would take forever. So I do need to pick and choose my battles. Right. So we've just gone over an hour. I think that's everything I wanted to talk to you about. So yeah, keep the feedback coming, and like I said, thank you for everyone who is a backer of 10x. And remember, if you want to become a backer, you get access to the Discord, where you can see exactly what I'm working on day to day and ask me questions anytime or report bugs at any time, and I'll jump on it straight away. So being a backer means you get sort of priority support, and I do my best to keep on top of all that. So yeah, it really does help me in terms of financially, and also for my motivation. Knowing that people really want 10x really does help me. So yeah, if you like 10x, please head over to the website, and you can support any amount you wish, and it's really appreciated. So thanks for that. And yeah, I'll see you in the new year. Have a good Christmas, everyone, and enjoy your holidays, and I will definitely enjoy mine. About time I had a break. So see you again soon, and enjoy using 10x. Bye for now.